Hello, ladies and gentlemen. This is a bit of a different video. This is just a video that's going to be like, I'm just documenting my AI progress. And this is sort of going to be where I'm up to in terms of like AI projects. And the reason I want to make this video is this is sort of like the first official AI project I've done. I've done a couple little ones that are like really shitty little things. This is like, when I say the first official one, this one's not using GameMaker, so it's using a proper language, C++. It uses the GPU as well, so I'm using Cuda and writing Cuda kernels, so I'm executing code from the graphics card, which makes it way faster. In theory, I don't know if it's actually faster, but in theory that makes it faster. And it's using, this is sort of like a very proper AI. Usually I just wing it and do my own thing. This one I tried to do like the proper way to do machine learning. So it's essentially a neural network that it uses like back propagation and gradient descent. I don't know what the correct term is. I don't think it's reinforcement learning. I think that's something else. But it's essentially I'm also doing sort of an official task as well, and that is I'm using the MNIST training data, which essentially what this AI does is you give it a hand-drawn digit and it's able to tell you what digit it is. So it's a digit between 0 and 9. So there's 10 different digits that there could be. And the AI calculates how much it thinks it is each different number. And then you basically just grab the one that it thinks it's the most, and that's its guess. All right. Okay, I'll show you. I mean, anyone who studies AI and does this code, like I'm at uni, I study, but I don't study AI, so my code's gonna be scuffed, obviously. My code's always scuffed. I'll show you kind of how it works. So this is the code. This took me a while, as you could imagine. I'm kind of winging it. It's mostly from scratch. I did get ChatGPT to help me a little bit where I got stuck in terms of like mostly just bug fixing and like not knowing how to do certain stuff in C++ because, you know, C++ is like a bit weirdo. But here's essentially, I think this is all the code. I don't think I have any headers or anything. I think it's all just in one file, which is also cursed if you do C++. All my classes are in the same file. Get over it. It's all good. It's my 900 lines. I'll go to the main and I'll show you pretty much how it works really quickly. And then I'll run it and you can see it train, see how long it trains for. And then it will basically guess a bunch of, it'll get given a bunch of numbers. I don't have a way of displaying the numbers right now. I definitely could add one, but you know how it is. I haven't done that. I'll show you the training data first. So if I open this file, hang on. So this is pretty much everything in the project. AI data. Oh my god, what are you so big for? So training data and testing data. So we use different training data and testing data. This is the MNIST. I wanted to use the MNIST. I saw a couple videos that talk about the MNIST training data or whatever. So I wanted to do this as sort of like an official. I have a bunch of different ideas for AI stuff. And I want to do a lot of experimental AI stuff, but I decided that I would do like a very cut and dry, not interesting AI project and a non-experimental AI project just to prove that I could do that first before I went to the experimenting, right? Sort of like wanting to write music, but you first learn how to play a certain song. It's kind of like that, right? Of course, I didn't follow any guides for actually coding it, so I just kind of did it from what I thought would be the way to do it. And I do have some decent knowledge. I'll show you. So the training data and stuff just kind of looks like this. It's pretty much just a number which dictates what the picture draws, like what the actual answer is of what it's supposed to be. And then you have all these numbers. If it's going to lag real hard. Oh no, it doesn't actually lag. And each of these numbers, so it goes along each pixel in our image, and each of the numbers represents represents how dark the pixel is. So like 0 means there's nothing there, like it's blank. Oh my fucking god, don't click. Oh yeah, okay, now it's lagging. All right. And so like for example, 253, it's out of 255, I believe is the max. Could be wrong. Or 256. I think it's 255 is the max value. Yeah, it will be 255. And so this is like a black pixel. So imagine this is like a white pixel and this is a black pixel. Like this is where the person's actually drawn numbers. So that's pretty, yeah, that's pretty much it. And each row here is a different number. And so this has 60,000 lines, which means there's 60,000 different numbers. And you can see these are all what the different numbers are. And when we train our AI, we basically just loop through every single one of these. We test our neural network on it. And then we do a thing called backpropagation, which I won't go into in depth into how neural network stuff works if you don't know already. I'm assuming you have some knowledge. But basically, long story short, we train it on all of the data in there. And the neural network adjusts itself to give better predictive power, is probably the best way to say it. So the way the actual main function works, or like this is, I defined a few different things, like a thing that controls the data and a thing that the actual neural network has a class. And you just give the neural network, you just basically say how big I want the neural network to be. So this one's 784, which is the amount of pixels in the image. So the first layer has to be 784 nodes. Fuck off. Trend. Sorry. And each other, you can put whatever you want for these middle layers, and you can have as many middle layers as you want. So I have 2 middle layers, each at 256 at the moment. That seems to work pretty well. I haven't tried it with like really large amount of layers or anything. I've tried it with 3 hidden layers. Doesn't really make much difference. Pretty much no matter what I change, it doesn't seem to get much better. Currently, I'm predicting the numbers with like just over a 90% accuracy. I don't know if that's very good. I've seen online that there's people who have made ones that are like 99% accurate, like 99.7% fucking accurate on the MNIST data. So, but they're using fancy smancy shit. I'm just doing like the most basic neural network possible, probably. And so you set a few variables like the rate of change, the max weight change, which is how much a weight can change in a like one backpropagation, I guess. And it just makes a new neural network, sets a few values, loops through all the training data, runs the neural network, and then does a rep. I use the word rep. I don't know what the actual term is, but I like the idea of a rep, as in like you're like bicep curling, right? So every time my AI trains, like, because it's like training. Training is like a physical thing as well, right? It's like physical training. And I was like, I was thinking like, what term should I use for one little bit of physical training, right? So we're gonna do it this is 600,000 times. I'm living it here, but the actual data is 60,000 times. 60,000. I don't know why it's 600,000. I mean, I'm training through it 10 times. I don't know if that does much. Not really, but anyways. Yeah, I was like a rep. A rep makes sense, right? I'm coining this term. If the word rep is not already used in AI training, I'm coining the term rep. It makes perfect sense to me. You do reps, and I guess you could call them sets. I don't know. But a rep would be like one backpropagation. I call that one rep. And we pretty much just output what the current accuracy is for the previous 1,000 loops. And the accuracy is defined by how close the actual answer is. How close the guess is to the answer. And when I say how close the guess is to the answer, it means like in our output layer, so our neural network has an output layer which is 10 different nodes, and each of those nodes represents how much it thinks that specific node is that specific number. So the first node will be a 0, or represents the 0, and the number of that node represents how much our neural network thinks that the data we've given it is a 0, or represents a 0, I guess. And it gives a number between 0 and 1. And when we train, we assume that, or like the goal that we give it for the backpropagation is that every incorrect answer is a 0, which means that ideally our neural network gives a 0 for every single answer that's not the correct one and gives a 1 for the correct one. Obviously in practice it's not going to do that, but that's how we train it. We try to get it to trend towards that, where it gives a 1 for the correct and a 0 for not correct values. If we have a look, so now it's just printing out. So I just make it so it just every 1,000 bits of data it trains on, it prints the total amount of accuracy for that 1,000 bits of data. And then that way you just see on the screen, when we run it and you'll see that we can see that it's actually training and it's actually improving because the inaccuracy gets lower, which is good. What else do we do? Yeah, so this is the training, and then we do the testing. So we have a testing data thing, and we basically run it against the testing data, and we tally up how many it gets correct, how many it gets wrong, and then it gives us a percentage correct. That's pretty much all it does. Is there anything else I probably need to show? Probably not. If you guys want if anyone's watching and they're an AI goon, I'm doing RelU. Am I not doing RelU? Causing issues. Okay, it's not causing. Okay. I don't know what the fuck. My comments are probably all fucked, by the way, because I don't change them. I think I just turned this off. I was doing RelU, and it wasn't giving better. So I was using Sigmoid. The Sigmoid squeeze. I was doing Sigmoid squeeze, which just squeezes the values between 0 and 1. Also, it does it for every single layer. It does the same. I know you can change it. Maybe in the future I'll change it so I choose which activation function for each layer. I'll probably add that next, to be honest, because that's pretty easy to add. I tried with RelU, and I tried with Sigmoid squeeze. I probably don't need biases. Whatever, fuck it. I don't know, whatever. I have biases in mind. The best, I'll run it with the biases. I don't know if it's any point having biases with Sigmoid. Yeah, I'm not sure about that, but I was using biases for the RelU, and I was working relatively well. I think my highest result is over 90%. And I'll show you what it also saves. It also saves the AIs as well. So if you have a look, after we run it, it will save the network. And so we can basically, and we also can load the network as well. So when I create it, I can put in a name of a text file into the constructor or whatever, and it will load it. I'm not sure what this true means, but sure, it isn't that complicated. And so when you save the data, I'll show you what it looks like. Is small save.data, whatever this is. Looks like this. It just saves what the structure of the network, and it saves each of these lines is the values of each weight in each of these. So there'll be 784 values on this first line, 256 on second, 120 on the third, and then the biases are here. So this is the biases. Same kind of thing where this is actually, no. This isn't 784 on this line. It'll be 784 times 256 on this line. And then this one will be 256 times 128, because each of the weights, there's 3 weight layers, and each of the weight layers are between the node layers, like there. And the number of weights is the multiple of the 2 nodes either side, because there's one weight connecting. There's one weight for every combination of nodes on the, I don't know if it's input, output of that weight layer. I don't know if that's correct terminology. The node layer on the left and right. Each node, each combination of nodes, there's a weight. So you have to multiply the value. So there's a lot of weights. That being said, the actual file is only 2 megabytes with this large, which is less. It's actually less than I thought it was going to be. I mean, I could have calculated it, but I did an AI project a while ago in Game Maker Studio, and it was a lot bigger. It was way bigger, the file size. So I don't know how much bigger than the neural network was I was doing. But That was a scuffed project. That was like, that wasn't using any of this sort of system. That was just using like a evolutionary model system. Anyways, point is, it's only 2 megabytes per AI, which is pretty small, which is cool. And if I run it, hopefully it just works. I didn't test this before I started recording, so there's like a high chance I just absolutely fucked it last time I was working on it, which would be very sad. If I run it, you'll see how it works. Actually, I'm actually gonna reduce the number of I'll make it 10,000 loops, so it doesn't loop through all the training data for this one. It'll give a shittier inaccuracy, but that's fine. Who cares? And I should be able to load the PB as well. I have a PB one here, which I believe got, unless I saved over it like an idiot, which is not impossible. It should be like 90 something % accuracy for the PB, unless I change the actual neural network code to work differently, in which case this PB won't actually work, which is actually quite likely because this PB is probably before I did biases. It might not be. I don't know. Not sure. So I might have to turn off the biases, but that's fine. So first thing it does is it loads all the data into basically into a class. And then you'll see here, it says how many weights, yada, yada, yada. How many nodes, how many biases. What it's doing is now it's looping through the training data and it's training. So you can see after 1,000 bits of data, we have this much inaccuracy. 2,000, this much inaccuracy. And this is the sum of the inaccuracy. So you can imagine the average inaccuracy per singular run is this divided by 1,000. So you can imagine like here it's 0.9, which is, I mean, that's okay, right? 0.9 is not good, but you can imagine if all of the data is 0.1s and our correct value is 1, that would be 0.9 inaccuracy. But yeah, it's probably going to guess like 50% correct, I would guess. Maybe a little bit more. But yeah, see, so now it's going through, it's running through all the testing data, and it's guessing. I didn't have to print all these off to the screen, but whatever. We did it. So it's probably actually the slowest part of this process is printing to the screen, hilariously. And if we have a look, how much did this get right? It's got 83% correct, so that's not too bad. If I did it'd be closer to 90% if I did the full 60,000 training data. But even at 10,000 bits of data, it's 83%. I didn't change. I could tweak a bunch of the values and stuff, probably get higher, right? I don't know what values I've got stuff on. It's not planned, so. But you can see here, like, you get to see what the guesses are. So here, the actual value of the image was a 9, and it guessed a 4. A lot of the guess inaccuracies are like a 4 and a 9 are pretty similar numbers, so they usually look like they're reasonable. I should probably get it to, I want to get it to draw things to the screen and then print out like what it got wrong and like show the images and stuff. But part of me wants to do that. Part of me just wants to move on to the next project. So I guess like here it was a 3, but it guessed it was an 8. Here was a 2, but it guessed it was an 8. 1 1 0 0 5 6 6 6 2 3 7 7. So it gets most of them correct, which is quite good. Here was a 1 and it guessed it was an 8. So yeah, it does get some error, some issues. It seems to guess 8s a lot here. It's probably a way I can like try and make it so it doesn't guess the same number that much, because the actual data, the actual training data is distributed like evenly, I believe, between the different numbers. So and see like here, this one's guessing lots of 8s and lots of 7s as well. And that's where it's getting things wrong. So ideally you could probably add some way to like weight it. So like if it is guessing 8s nonstop, then the actual neural paths, or maybe even just the final node, gets scaled down, just because it's addicted to guessing 8s, just to make it guess 8s less, if that makes sense. So that I could probably add something like that ideally to this, but because it does have the issue of like having certain numbers it prioritizes in guessing as opposed to being sort of even. So I could scale them or add some kind of scaling system. Probably a smart thing to do. We probably won't do that. Anyways, I run the PB loop. It's probably going to give a terrible result. All right, let me... Definitely the neatest code ever written here. Let me write the PB... What's it called? PB save. Okay. Like that. I think capitals matter. What's is true? What am I doing here? Load now. What the fuck is load now? I don't know what that is, but I'm guessing we do want to load now. So, world's greatest programmer, boys. I don't even know what my own shit is supposed to be. Reading my code is like having amnesia. It's like I should know, but I don't know. Should be clear, but is always just confusion. So it's loading the data. The loading from the data takes a while, actually. And that's just reading all of the files. Just reading all the lines of data out of the training data file, sticking it into the controller. It also, I'm pretty sure the loading, even though I said 10,000 for this loop, it's actually loading all 60,000 as well. So I can probably change that. So off the bat, you can see the section inaccuracy, like, because we loaded this one in, it's like 335 off the bat. It shouldn't be getting better. If it's getting better, that's kind of strange, but there is a bit of variance in terms of these. I don't know if you guys can see this shit very well. There is a bit of variance in terms of these numbers, and that's just because, like, you can imagine out of every 1,000 bits of data, some of these thousands are easier to guess, like the numbers, and some of them have higher frequencies of numbers in them. I don't know, actually. I'm sure it's probably pretty consistent. But you can see here, like, for example, here's what a guess looks like. Holy fucking shit. All right, it's going off. Never mind, we don't get to look at what the guess looks like. But you can see there's a bunch of, like, zeros. And it had one number that had a higher value, which is what the guess is going to be, whatever the higher value is. This is the PB. You can see it's going through the training data. I'm actually curious to what the number will be. I think it's going to be like 90%. If it's less than 90%, it means I've changed something in the code that makes it less inefficient. But considering how low the numbers were, where it was like about 300, which is about a 0.3 accuracy, it should be about 90%. Okay, yeah, so you can see it has 90.8%. So this is about the best that I've been able to get with the system that I got, which does train fairly fast. Like it would get to this in about, if I did it over the full 60,000 from scratch, I'm pretty sure it would get to this. I don't think doing like 100,000 or 200,000, a million iterations does anything. I think that just doing it over the 60,000 bits of data seems to work. And you can see, yeah, just under 91%. So it's pretty good. I'm happy with this. That's why I'm showing you guys, because I'm actually pretty happy that this works, because this is the kind of project where it does absolutely nothing until it doesn't. So like there's a whole bunch of little systems you have to do, and then it will actually work. But I was doing literally nothing until it just worked, and then I was happy. And I did have to fix a lot of bugs, and there was a lot of like I basically got to this point where I had a lot of stuff, but it was not actually improving as well. So I had to work out why it wasn't improving, and I had to fix. There's a whole bunch of issues, obviously. There's a whole bunch of issues I had to fix. But yeah, I wish I could show you guys. Yeah, so you can see for the most part, like a lot of them, it's very confident, like has very small inaccuracies, which is good. That means that it's like pretty much just saying the correct answer is 1. And you can see that like, how is it possible that it's a 0.08 error and it guessed the wrong number? Oh, okay, because the error is on the top. Okay, it says the error and then the value. Okay, I'm trolling. So error of 1, and then it was incorrect. Okay, that makes sense. You see the ones where it's got higher total errors where it's guessing incorrectly, but then there's a lot that it has very high confidence in. So like this has very high confidence. This one has not as high confidence, but still got it correct. And yeah, that's basically the project. And I'm probably gonna adapt this into some different projects. And I got a whole bunch of crazy. I'm excited because this is like the more boring project, like the test project, I guess, to test. This was sort of to test the CUDA GPU stuff. The way I'm doing stuff is probably like turbo inefficient in general, but it's gonna be like, it can't be that inefficient, right? Like it's using the GPU. I got GPU kernels. I'll show you. I got kernels running the code. Like we're running these simultaneously on the GPU, so it can't be that bad. It can't be that bad. It's not gonna be as efficient probably as the proper AI. The proper AI stuff. I'm not sure how efficient like TensorFlow and stuff is, but I'm sure they like absolutely just roll whatever I'm doing. But the thing about my thing is that I've done it from scratch, and I can like fully edit it, and I can do some absolutely crazy whack shit. I got some really crazy whack ideas, and I'll probably upload them in future videos once I've programmed them. And I also want to make a chess AI, that's not very interesting, but that is on the must-do list. The chess AI is on the must-do because I wanted to do it. But yeah, there's a whole bunch of awesome AI projects that people still haven't done, which is awesome. There's a lot of potential. So yeah, this has been my first proper AI project. At least the first one that uses like proper gradient descent backpropagation. I don't know what it's called. I keep thinking like reinforcement learning, but I don't think that's right. Something else. Reinforcement learning is something else. Reinforcement learning. This is not reinforcement learning. What the fuck's it called? Someone in the comments tell me if you guys know what the fuck it's called. I forget. Because there's a few different types of learning, but I just fucking confuse them. What is it called? Once I hear it, I'll be like, yeah, that's the one. I don't think it's reinforcement. I think reinforcement is something to do with like you're kind of rewarding. You come up with a system that rewards the thing, which is not really what we're doing. This is just like training on data set, which is probably the most common. This is probably the most common sort of AI, but it's also kind of like the gayest, to be honest. I like the evolutionary ones. Evolutionary ones are way slower, but they're danker, absolutely dank. So I'm going to try doing an evolutionary chess AI, and I'm also going to try doing a chess AI that trains off of puzzles, like sort of like using this kind of system, but we have puzzles where we have the definitive known answers, and we only train it off puzzles, and then we get it to play on actual chess games and see if it's actually any good. That'd be fucking sick. I don't know if people have done that before. Probably, like that's more than likely, but I couldn't really find very good chess data sets for puzzles. So I'll probably have to make my own data set. So I'm gonna have to do some crazy shit for that. Pretty much. I'm gonna have to do some crazy shit for the puzzles, for the puzzle data set. Anyways, thank you for watching. I'll see you guys in the next video. Much love.